All right. What is up, everybody? Tom McGurl here with another night of Rust. That's right. We're going to be doing more Rust, finishing up the Rustlings exercises, and then if we have time, moving on to Chapter 11 of the Rust book, which is on unit testing and testing your code. So something we've been getting a little bit of exposure through Rustlings, right? Rustlings is running tests, and we've seen assertions, but getting a little more into that. So, as always, if you missed any of the previous chapters, do not worry. They are all here on YouTube. Just constantly got to plug the YouTube because we have all the videos here. Easy watching. You can watch it at your own speed, whatever you like. Our recent one, we did Rustlings. It was a little Thanksgiving special. You got the turkey there. The Rustlings so far, we started 2 weeks ago, so we have part 11 and part 12. Those are both Rustlings. Also put a one-off video up there to do Rust in Docker, basically for development. So that's pretty cool. A little short video, only 14 minutes. And then all the previous chapters of the book can be found here in the video section. You can see we have chapters 1 through 10. Chapter 10 was a big one. We got through it. It's pretty great. We also have some other videos like learning how to code a serverless backend API with AWS Lambda, TypeScript, Node.js, DynamoDB, and S3 for image storage. We've also done some React Native development with Expo. We tried out Recoil.js. We also built that with TypeScript, and that was a lot of fun as well. So definitely check those out. If you want to get updates on when more videos get posted, feel free to subscribe to the channel and like the videos. It's always appreciated. Also, if you want to get updates on when I go live, I always tweet it out. You probably already realized this if you're following. If you're watching on YouTube after the fact, follow the Twitter. You'll get live notifications, and I usually also post when I put videos up. All the stuff we do is going to go up on GitHub. So we have our Learn Rust Live here. That's the chapters of the book that we've gone through. All that code's pushed up there. We have the serverless API here. We have the React Native app. Some front-end resources that are a bit out of date, but I'll be updating those as well. So definitely check that out. Today, we're wrapping up Rustlings. What is Rustlings? If you haven't been following along, Rustlings is a tool that you can run. It's like a CLI tool that will run a bunch of different Rust exercises. It runs a test scenario, and basically it watches for changes in your files, and you have to make changes to make the code pass. It's been a really great thing to go through because it's letting us flex some of the muscles we learned while going through the book, using collections, using constructs like enum, right? Using types, using functions, using vectors, modules, things like that. We even got some exposure using Clippy, macros, which we haven't dove into yet in the book, but it's pretty cool that we're getting to use it. Dozeboy in the chat, what is up? Welcome. Thank you for stopping by. I appreciate it. So yeah, definitely check out the Rustlings there. This is what we're going to be doing. And then we'll go into the book. We'll get there. If we get there, we'll get there. Patatas is back. Patatas is a usual suspect in the chat. Always happy to have him here. Appreciate it. So let's go ahead and kick it off. So what we're going to do today, again, let me just close my stuff out here so I don't get notifications. All right, so we're going to start out with Rustlings, and we're going to look at where we left off. Let me just clear this out. So like I said, Rustlings is going to run a watcher that's going to allow us to watch for file changes and stuff. So to get that started, I'm in my Rustlings folder. We have some of our old exercises that we went through. I can just close some of these out. We did errors, we did option, we did result type, we did Clippy. So what I'm going to do is run Rustlings watch, and that's going to kick it off. It's going to show us all the stuff we've done already. So variables, if, functions, we did a quiz, primitive types, structs, we did more quizzes, strings, tests, enum, modules, collections like hash map and vector, macros, move semantics, which talks about borrowing and ownership. And now we are on to box. We haven't learned about box, so it's going to be fun. We're going to be using the tips as needed. Vias01, first time joining live. Well, happy to have you. Always a pleasure. And Jeff Feronius. Jeff Feronius made it. You made it on time. Yay. Jeff Feronius, notorious for popping in at the last minute, but glad you made it here today. Awesome to have you. Not doing AOC. Patatas, great question. We actually I was thinking about doing the advent of code, but the thing is, since we're only doing it once a week, I'd have to catch up on 7 days worth. So maybe I'll go through it and pick a few that are interesting and try doing those. So that's a great idea, and definitely something I might try to do. That would be a lot of fun. If anyone doesn't know what AOC is, it's called Advent of Code. It's a really cool little hack challenge in the month of December where there's different problems every day and you try to solve them in the language of your choice. So it could be a really good example for Rust. So what I'll do is I'll check it out. I'll go through and see what ones we can tackle on stream. I think that'd be a lot of fun. So shout out to Patatas for calling that out. It's awesome. All right, so box. We haven't learned about box. We've used it a little bit. And I'm just going to quickly pull up errors because we used it a bit in errors. If anyone remembers from last time, and it was towards the end of the stream, so if you're watching on YouTube, the previous video towards the end, we used box as like a catch-all to catch a bunch of different error types. So we caught the standard error here, we caught an IO error, we caught a format error, and we just kind of used the box to catch that error type. So it was pretty cool. So now we're going to dive into box 1. And so you can see here it's saying box 1 is failing, and it gives you the output. Recursive type has infinite size. So it says here, insert some indirection, example, a box, RC, or ampersand. So we're going to use a box, most likely. So let's open up box 1. Let me get that out of the way there. All right, let's see what we got. Box. At compile time, Rust needs to know how much space a type takes up. This becomes problematic for recursive types, where a value can have, as part of itself, another value of the same type. Example. If you're coming from JavaScript or Python, let's talk about JavaScript. It's an easy example. Let's imagine you have an array of arrays, or an object that contains another object. So recursive types. Or let's say, for example, let me think of a good real world scenario. Let's say you're a person, and the person object has a friend property, and the friend references another person object. That would be a circular kind of dependency there, and that's what we're talking about with recursive types. So you can have, as part of itself, another value of the same type. To get around this issue, we can use a box. A smart pointer used to store data on the heap. Again, remember in Rust, we can store data on the stack or on the heap. The heap is used for when we don't know, how much size something can take up, right? Which also allows us to wrap a recursive type. Okay, so we're going to be able to wrap a recursive type with box. The recursive type we're implementing in this exercise is the const list, a data structure frequently found in functional programming languages. Each item in a const list contains two elements, of the value of the current item and the next item. So almost like a continuous list, think of it like a linked list, so the value of the current item and the next item. The last item is a value called nil. So to dive in a little deeper, what this is it's going to have two values, the current value and then the next item. And that item will also have a value and a link to the next item, or if there's no next item, it'll be nil. So step 1, use a box in the enum definition to make the code compile. Step 2, create both empty and non-empty cons lists by replacing unimplemented. Note, the test should not be changed. Execute Rustlings hint box 1 for hint. So we'll probably have to do that because we haven't used box yet. We haven't learned about it in the book. Maybe some of you in the chat have learned about it. I know Patatas has definitely done some Rust, so he's got experience. But we're going to try to use the hint and see what we can get from the code itself. So let's see what we got. We got derive. So these are some traits. We have debug and partial equality. We have a list enum, and here we have the cons. It stores an integer 32, and then the rest of the list. And then we have nil as the last value. So let's see what the main function is doing. It's printing. This is an empty list. This is an empty cons list. And then it's calling create empty list. And then it's printing this is a non-empty cons list. And it's calling create non-empty list. So these are two functions. The first one, create empty list, is unimplemented. So we'll have to implement that. And the second one is unimplemented. So it's step 2 says we'll have to implement that as well. So here we go. Okay, so let's see what the tests are looking for. That should give us a little help. Patatas, this exercise is literally in the standard docs for box. That's awesome. I bet a few of these are. That's really funny. So Patatas in the chat mentioned that if you look at the docs, the standard docs for box, they have exercises, and this is the one from there. Apparently, that's awesome. Okay, so for the test, we have test create empty list. So it assert equals, so this is a test, which we're going to read about in chapter 11. Assert that list nil is equivalent to create empty list. So it should return list nil. Assert that a non-empty list, so they're asserting not equal empty list, non-empty list. So it's just asserting that an empty list is not the same thing as a non-empty list. So pretty easy assertions. We're not going to change the tests. But let's look at what our error says and see what information we can get from that. And then if we can't get enough information there, we'll leverage our Rustlings hint. So here we see recursive type list has an infinite size. Pub enum list, recursive type has infinite size. Recursive without indirection, so it's pointing to list. And then here it says insert some indirection. And it add a box. So let's see if we get a little more info from this message. So we'll try that in a second, but let's see what else it says. Cycle detected when computing drop check constraints for list. And it's a cycle of a list containing a list, a recursive cycle. Note, which again requires computing drop check constraints for lists completing the cycle. Note, cycle used when computing drop CK types for canonical, blah, blah, blah. Okay, let's try the suggestion that it says there. Let's surround list in a box. And I'm sure when we get to that chapter, we'll learn why. Let's go ahead and save that. Okay, so we compiled. Now we have to implement the list type. So here we see our test failed. Here we can see how many successes and what failures. So they both failed. So we have 2 failures. The first failure here says test create empty list. So that's this test right here, test create empty list. And it's saying it panicked at not implemented. That's because we have unimplemented there. So let's implement it. So it's expecting list nil. So let's go ahead and try returning that. Let's see if that solves the first one. Okay, so test create empty list passed, but we still have a failure, and we have a failure on create non-empty list. And so here it says create non-empty list panicked at not implemented because we have to implement it. So let's try implementing a non-empty list. What could that look like? So we'll do list, and you can see here the different options for list are cons I32, right? So what we'll do is we'll try and here we'll do cons I32 nil. Or you know what we can do? We can do, since it's a list, we can do list nil. Let's see if that works. Okay, so it's complaining because it needs to be boxed, but we made a little progress. So I32 is not a value. That's okay. We'll give it a value. We'll say it's 117. I'm a big Halo fan, so I'm gonna have to go with 117 for this. Let's see if we can clear up that first one. Great, so the first one's cleared up, but now it says expected struct box found enum instead. So what we can do is it's telling us right here, and this again is why I love Rust and why we keep coming back to it. We're gonna get these awesome error messages that are gonna, just gonna adjust that are gonna tell us what to do, and we're gonna lean on that. You'll hear me say this all the time, lean on the compiler, lean on the compiler. And that's just to say that when the compiler throws an error, it's not you're not doing something wrong. In fact, you're doing something right. Sometimes you can leverage the compiler to give you information and give you answers when you get stuck. And this is a perfect example. So let's try doing that. Let's do box new list nil. And there we go. It compiled. Now, before we move on, I want to try one other thing. I want to create a box new with another cons list in here. So let's go here. So let's try, instead of list nil, let's do list cons. We'll do 1337, and we'll do list nil. So it's a little bit recursive looking, and we'll do box new and see what that looks like. So you can see the recursion a little bit. So we're still good. So you can see here, the second value again is a list. And so I created another non-empty list here. And again, our test is just checking that create non-empty list doesn't create an empty list. It's not checking what the list is. So pretty cool. I'll just go back and leave it in the simple case there. So awesome. So what we can do now is we'll get rid of this I am not done, and Rustlings will move on to our next exercise. Pretty cool. All right. Arc 1. What is an arc? What is an arc? We're going to find out. So let's open up Arc 1. Arc 1. Make this code compile by filling in a value for shared numbers. where the to-do comment is... Okay, so sorry, I read that wrong. Make this code compile by filling in a value for shared numbers where the to-do comment is, and create an initial binding for child numbers somewhere. Try not to create any copies of the numbers vector. Execute Rustlings hint for a hint. All right, not a lot of info. Let's try to read through and see what we're dealing with. We have our main function. We're supposed to try not copying it. And Patah says this one seems like a pain. Yeah, it does. It doesn't have much info. So let's see what it's doing. So forbid unused imports. Do not change this in the next line. So it's basically saying you have to use all the imports. So we have to use arc. It's forbidding unused imports. That's all that means. So let numbers vec, and we have a range from 0 to 100. This is just specifying that the range is not going to be an signed 32-bit integer. It's just saying this range is going to be an unsigned 32-bit integer because, of course, it defaults to a signed 32-bit. And then collect. So that's going to convert it to a vector. Now, what we have here, and the reason for the underscore, I'm assuming, is because it's getting its type from here, so it doesn't know it necessarily in advance. No big deal. Let shared numbers equal to do. So that's what we have to fill in. Let mute join handles. So join handles is a new vector. It's a mutable vector. And then what it's doing is for offset in 0 through 8, join handles push thread. Oh, we're getting crazy. Pushing threads? We don't learn about threads yet. That's all right. Figure it out. It's pushing a thread. So it's spawning a new thread and pushing it onto join handles. What does the thread do? Move or let mute I equal offset. So I is going to be equal to 0 through 8. Let mute sum equal 0, where I is less than child numbers, which is create initial binding for child numbers. So we have to create the initial binding. I was going to say it doesn't look like it's defined. So while I is less than child numbers, that length, sum plus equal child numbers I. So it's going to add them, right? So sum's going to start at 0, and it's going to continue to add the numbers in child numbers. And then I plus equals 8. All right. Sum of offset is, and it's going to print the offset and the sum. And then for handle in join handles, turn it into an iterator, handle.join unwrap. Interesting. A lot going on. Might have to use the hint for this, but let's see. Let's look up arc. I think that's going to help us. Let's look up arc. So I'm going to go over to here. Arc. Let's read a little bit about this first. Arc is a thread-safe reference counting pointer. Arc stands for atomically reference counted. Atomically reference counted. Arc. Atomically reference counted. The type arc_t, so arc over type t, provides shared ownership of a value of type t allocated in the heap. Invoking clone on arc produces a new arc instance, which points to the same allocation on the heap as the source arc, while increasing a reference count. When this last arc pointer to a given allocation is destroyed, the value stored in that allocation, often referred to as the inner value, is also dropped. Patah said in the chat, friendship with garbage collection has ended. Arc is my new best friend now. Yeah, this is interesting. Shared references in Rust disallow mutation by default, and arc is no exception. You cannot generally obtain a mutable reference to something inside an arc. If you need to mutate through an arc, use mutex, RW lock, or one of the atomic types. So again, let's just go over this first part. It's important. It's a thread-safe reference counting pointer. Atomically reference counted. It provides shared ownership of a value of type t, so it's a generic type, whatever the type. It creates shared ownership of that value, allocated in the heap. Invoking clone on an arc produces a new arc instance, which points to the same allocation of the heap as the source arc. So if you clone it, they point to the same allocation, while increasing a reference count. So it has a reference count, it's increased. When the last arc pointer to a given allocation is destroyed, the value stored in that allocation, often referred to as the inner value, is also dropped. Okay, so it gives you a reference, right? Shared ownership of a value. So let's see what that means here. Let's try to understand this. It's a little bit complex, but let's see. So clearly numbers, which we're supposed to not create copies of, but we have to create an initial binding for child numbers. So make this code compile by filling in a value for shared numbers where the to-do comment is, and create an initial binding for child numbers. So we obviously have to use an arc. I'm gonna go for the hint here. Let's see. We're gonna execute this command. Let's get a little hint from our rustlings here. Rustlings hint arc1. I said hist. All right, let's see. Rustlings hint arc1. Make shared numbers be an arc from the numbers vector. Then, in order to avoid creating a copy of numbers, you'll need to create child numbers inside the loop, but still in the main thread. Child numbers should be a clone of the arc of the numbers instead of thread local copy of the numbers. Haven't learned arc yet, so this is a little confusing. But let's see. Let's try to use the old compiler to help us out. So it says shared numbers should be an arc from the numbers vector. So what if we did arc new numbers? Let's just compile, see if that compiles. So what I'm going to do is I'm going to run rustlings watch again. Actually, let's do this. We'll run it. Let's run this. What we can do is we can just run rustlings on this so that we don't have to keep going through all of our successful tests. I know it's very nice to see how successful we have been, but it's kind of a pain to wait, right? Okay, so let's see what it says here. Okay, so it didn't complain about that. Good. But it is complaining that child numbers is not defined. So let's look again at what this is doing. So shared numbers is a new arc. Where are we using shared numbers? We're not using it, but it's saying that filling in a value for shared numbers where the comment is and create initial binding with child numbers. So shared numbers is here. We're not creating copies. So we have our offset 0 to 8. Join handles is a vector where we push a new thread while I is less than child numbers dot length. So again, I is equal to offset. So I is just going to be equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, and so forth. So I is equal to that. So while that's less than child numbers length, sum, which is starts at 0, equals whatever is at index I in child numbers. And then I plus equals 8. So we're going to jump 8, right? Okay, so let's see. And then at the end, we're doing for handle and join handles into iter handle dot join unwrap. All right, let's give it a shot. Let's see what we can get. Let's see what we can get out of here. So let's try creating child numbers. Okay, so create an initial binding for child numbers. What did our hint say? I'm going to do this really quick. Run that hint again. Child number should be a clone of the arc of the numbers instead of a thread local copy of numbers. Okay. So it's got to be a clone of the arc. So what if we did, let's see how to make an arc clone. So we're going to go over to here. Let's see how to clone it. Cloning references. Creating a new reference from an existing reference counted pointer is done using the clone trait implemented for arct. There are two syntaxes, both are equivalent. Arc clone, or you can just call that. So we'll do that. Let's do the first one. So we'll do child numbers equals shared numbers dot clone. And now we'll just run rustlings. I believe, let me go to the README real quick. I believe we can just run the single exercise. Let's see. So we have rustlings watch, rustlings run. Okay, so that's what we want. We're going to run rustlings run on just this exercise. We did it. Patatas in the chat. I prefer arc clone foo because it's explicit that you're cloning an arc. I also like it because it seems to me more functional. I know it's not necessarily because we're creating a clone, but I do like the idea of using arc clone. So just what we're talking about in the chat here for those following along on here. Instead of writing it this way, we can write. So here I created shared number. And the reason I created shared numbers out here was because the hint said we had to create it in the main thread, but outside our scope here, right? So what I'm going to do is the other option was to write it like this. And you get a reference to shared numbers. And everything should work. So I'm going to run Rustlings watch again since I think we got this to pass. And I'm not totally sure what this is doing, but I think as we go through the book more, we'll figure it out. So in the chat, Patatas is saying, normally you see clone, and I think it's an expensive clone instead of a cheap +1 to the reference counter. Interesting. Foo function as, I believe you can write every function as foo type function. Ah. So yeah, basically any function can be written that way. That's pretty great. All right, so this is passing. So because I'm like not totally sure what's going on, and I think we'll get there when we cover the book, we'll return to this. Once we learn more about arc, we will return here and see what's going on. Iterators 1. All right, let's go. So we're in uncharted territory here, but I like it. It's fun. We're leveraging the hints, and they're good hints. All right, so we have 4 iterator sections. So let's see if we can figure this out. Iterators 1. Make me compile by filling in the question marks. When performing operations on elements within a collection, iterators are essential. This module helps you get familiar with the structure of using an iterator and how to go through elements within an iterable collection. Execute Rustlings hint for hints. Okay. Let's see what's going on. So we have to modify the question marks. We have to make a compile by modifying these. So let's see what we have. We have favorite fruits. Banana, custard apple. Whoa. What? Custard apple? It's not our favorite apple. Come on. Golden Delicious fans, where you at? Underrated. Best underrated apple. Golden Delicious apple. Avocado. Weird that that's a fruit. Okay. Peach and raspberry. Pretty cool. Okay. So then we have immutable, my iterable fave fruits. So what are we going to do? We're going to do my fave fruits dot to iter, which I've seen, and the reason I know to use it is I've seen it. Now we have to fill in these other question marks. Let's do it. My iterable fave fruits. Next, some banana. So it's just asserting that the iterators, although I don't know in Rust what they are, I have a sense for iterators from other languages. We actually had them in JavaScript. If you've ever used a type like a generator, you can think of that as an iterator. It allows you to iterate through values, right? So an iterator will give you values. And some iterators will actually consume those values, meaning if you have an iterator, and once you've called .next on it, it's actually removed from the iterator. .next is going to allow us to feed each of the values. So we say next, we get the next value. Say next, we get the next value. So let's see. I believe this should be into iter. Okay, so what this is doing is just checking our tests. So we're going to go ahead and change this. We're going to copy it here. And of course, we're going to deal with the Golden Delicious apple. Best apple, best apple. Actually, pink ladies are also a fantastic apple. Can't deny the pink. Got a little tartness, got the big crispiness to it. Pink ladies are great. Golden Delicious are like the other side. They're a little sweeter, but I gotta like them all. All right, so let's grab peach. Oh, to do step 2.1. What does it want us to do? Oh, I see what it's gonna ask. So here, next, there shouldn't be anything here because we're out. And my guess is that, I'm just guessing. Oh, I'm guessing it's going to return nil. I messed up. Peach. Expected string, found string slice. That's because, let's see, banana, golden delicious, avocado, peach, raspberry. Let's see what it says. Expected string, found string slice. Okay. So what are we doing wrong here? Banana worked. Let's see, did they work? No. And nil's not a thing. So let's get rid of that last one. Oh, sorry about that. And so none of them were working, but that's okay. What we can do is we can do some. Let's see if that makes it. Good. We can do this, 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 this. All right, so that's gonna fix our strings. So now we just need to figure out what the last one is. And so let's try a few different things and see what it says. Patatas in the chat said, try iter. Now it's gonna be a string slice. Great, okay, so we can have into iter or iter, and if we do just iter, then we don't have to change those tests. I like that. So there's a difference clearly between into iter and iter. All right, so that lets us not have to change those tests. That's great. And now for this last one, let's do, since it's either some, right? We're dealing with an option, some or none, right? So in here, it'll be none. All right, assertion failed, left equal right. Peach, some peach, avocado. That's easy. That's just this here. And we should be good. All right, let's go over what we did. So here we have my favorite fruits. It's a vector. We called the iter function. Now let's look up what the iter function does, just so we're clear on it. If you found yourselves with a collection of some kind and need to perform an operation of the elements of said collection, you'll quickly run into iterators. Iterators are heavily used in idiomatic Rust code, so it's worth becoming familiar with them. All right, iterator. Here's an iterator. So let's look for the iter function. There are three common methods which can create iterators from a collection. And remember, our vector is a collection. Iter, which iterates over a reference of type T. Itermute, which iterates over a mutable reference type T, and into iter, which we accidentally tried using to begin with, which iterates over T itself, right? So not a reference to it. So that's the difference. And so we used iter. So we're getting a reference. So here we have banana, golden delicious apple, avocado, peach, raspberry. And then if you look, because we have some in front, that's indicating to us that next is going to return an option of either some type or none. And so here we know we've run out because raspberry is the last thing on our list. So we know it can't return some string slice. It's going to have to return none. And we could probably find that out by looking at next implementation. And you can see next is going to return an option. So we are indeed correct. So here we have some. And here we have none because we're out of values. So just like an option, if there's no value, it will return none. So pretty cool. And we are passing. So now let's go ahead and remove our I'm not done. Yes, so the important thing about iter, which we're talking about here because it returns a reference. So Patatas made a good point. It won't take ownership, right? But if we used into iter, it actually would. So pretty cool. So let's see what's next. All right, iterators 2. Let's pop that open. Iterators 2. In this module, you'll learn some of the unique advantages that iterators can offer. Step 1, complete the capitalized first function to pass the first two cases. So that's what we have to do first, complete that capitalized first. Step 2, apply the capitalized first function to a vector of strings. ensure that it returns a vector of strings as well. Step 3, apply the capitalized first function again to a list. Try to ensure it returns a single string. As always, there are hints if you execute hints. All right, so first, step 1, we're going to try to complete the capitalized first function to pass the first 2 cases. So let's look at our cases and see what they do. The first case, test success. Assert that capitalize first when passed hello will return hello with a capital H, right? Pretty cool. The second case says when an empty string is passed, an empty string should be returned. Okay, so let's see what's going on here. In our capitalize first, it takes a string slice and returns a string. We create a mutable C from the characters of input. And again, we're using characters because we want to iterate over each character, right? Not each byte, each character. That's important. Match C. So we're doing a match on C.next. So now we're going to iterate over it. But of course, cars is not iterable, so I'm sure C.next is going to complain. So if we look at the complaints here, we can probably see. Well, cannot find value capitalized words in this scope. So let's do this. So it wants to iterate over C. Maybe cars does return it. Let's look up what cars returns. Maybe it does return an iterator. Cars. An iterator over the cars of a string slice. Okay, so it is an iterator. That's good. So that's not the problem. So we match on next. If it's none, meaning there's no value left, right? We return string.new. So that's just a new string, an empty string, right? So one thing I just want to bring up from the chat, because this is interesting. An iterator can return some after returning none. This is interesting. Unless it's a fused iterator. Interesting. That sounds pretty nutty. But that's why this match case is pretty great, right? Because we can match on C.next and see what we get here. So if it's none, right? And we're only going on the first one because we're only capitalizing the first letter. We don't need this to be in a loop. We're not going over each character. So we're looking at C.next. If it's none, return new. Otherwise, if we get the value, first collect string plus C as string. And so let's see what we have here. So first it's saying a function with similar name exists, capitalize first. Capitalized words we haven't implemented yet, so that's why that's complaining. Let's see here. Method not found in car. The method collect exists, but the following trait bounds were not satisfied. Car iterator, which is required by mute car iterator. All right, so what we'd have to do here is, let's see. The method collect exists, but the following trait bounds were not satisfied. Iterator, which is required by iterator. So let's see if it's the case that we need to make an iterator. Okay, so let's see if that helped out in any way. No, method not found in car. All right, so let's go back and see what this could be. Let's read a little bit more into these messages. Capitalized word, we know that doesn't exist yet. Method not found in car. So again, this method collect exists, but the following trait bounds were not satisfied. So let's try to decipher this. Car, standard iterator, which is required by mutable car, standard iterator. Okay. What else? Capitalized words, we haven't defined. That's okay. Capitalized words. All right. Let's use the hint. So what we'll do is we'll do Rustlings hint iterators 2. Step 1. Let's look at that. You'll need to call something on first before it can be collected. Currently, its type is car. Have a look at the methods that are available on that type. Awesome. All right, let's look at the methods available on car and convert it to something that convert it to something that collect can be called on. So let's do that. So let's click here. Blue. All right, so car. We want to call collect on it. How are we going to do that? Let's see what functions we have. From U32, from U32 unchecked, from digit, is digit, to digit, escape Unicode, escape debug, escape default, len UTF-8, len UTF-8, encode UTF-8, is alphabetical, is lowercase, to is uppercase, is whitespace, is alphanumeric, is control. I'm going to do a little search here. Okay, so 2 lowercase. We're in the 2's now. 2 uppercase. Is ASCII. Let's see. Let's look for 2 ASCII, 2 digit, 2 string. Let's try that. So let's see what that does first. 2 string is going to, let's go to 2 string. Oh, don't want to do that. So 2 string, let's see where that is. So first they're calling escape Unicode on it. So let's see what else. We have 2 digit, 2 ASCII, is control, from digit, is alphabetical, that's not what we want. Let's see. So we got to figure out how we can call collect on. So, I have an idea. Why don't we look at what collect does and see what type it needs to be. Iterator. All right. So collect. So this is interesting. Here we're getting the cars, enumerate, collect. So that's interesting. So maybe it is the case that we just need to make an iterator. Let's try it. Let's go back to car and look for iter as an iterator. Escape default returns an iterator that yields the literal escape code of the characters as car. All right, let's try that. All right, and then what we're gonna do down here is we're gonna run Rustlings run iterators 2. All right, so it's not complaining about that anymore. It's just complaining that capitalized words is implemented. So we'll go over that in a second. Let's just take a look at step 2 and see if we can get that. Apply the capitalized first function to a vector of strings. Ensure that it returns a vector of strings as well. Okay, here's step 2. So step 2 is test iterate string vec. So let words equal vector hello world. So we need to make sure that we can apply capitalized first function to a vector of strings, ensure that it returns a vector of strings as well. So we have words, it's vector of strings, capitalized words equals vec string, and then we have to make the to do. Assert equal capitalized words, hello world. So we want to, for each item in the vector, apply capitalized word on it. capitalize first. So what we can do is we can, well, so let's see. So here what we can do is capitalize. Well, we can do it the old school way and just loop over it. So we can do let's just write that out first. So we'll do for word in words, right? For word in words, and then we can try setting equal to this. So for word in words, we're going to call capitalize first, and we're going to put word. Let's run it. Capitalize words, capitalize first. Oh, try adding a semicolon, right? So let's do this. Well, capitalize first returns a string. So actually what we want to do is see what this does here. So what we're trying to do is iterate over it and return the words. So here, let's see if we messed up this stuff. Mismatch types. Capitalized word, vec string. Expected struct vec found unit type. Because, let's see if this does it. Okay, so this isn't returning anything. So, whoa, what up? DNC bro with the follow, appreciate it. Thanks for following. All right, so let's see what's going on here. So first what I'm gonna do is I'm just gonna do this. So this is our loop over word in words. We're gonna call capitalize first. And we don't wanna modify capitalized words because I don't think the Rustlings wants us to do that. All right, so let's see. Capitalized words, vec string. So we have a string. We have a vector of strings. For word in words, which is this here, we're going to call capitalize first with the word. And we want to put this into here. But we don't want to make this mutable. So we need to just do the assignment. So what if we did... Is there... Let me see something. Is there list comprehensions in Rust? You can use iterators. Duh. Of course we have to use iterators. Collect. So here I'm just looking at an example here. I was looking for something like a list comprehension, right? Because what I want to write, like if this is Python, right? What I want to write here is capitalize first word for word in words, right? That's what I want to do. That's the Python engineer. That's actually not in me. It's not like I can say the Python engineer in me. But having used Python, I want to do something like that. Or having used JavaScript, I would want to use a map, right? We would just do, words.map, capitalize first. But here we want to use an iterator. So I'm looking at this example here. It's very grainy, probably on the video. But let's take a look at what they're saying. Python list comprehension is really simple, right? Does Rust have equivalent syntax? And so we can just use iterators. v1 equals filter. So we want to use something like map, collect. Could try using that. Let's see. Can we use map on a vector? Let's try it. So we do words.map, and we have to give it a function, an inline function. So we'll just take word, right? That's the syntax for the inline function, which you can see here. And we'll do capitalize first word, and then we'll collect that, which is what they're doing here, collect. collect into a vec, and in our case, string. Let's try it. Patatas. Let me tell you a tip. 2 uppercase. There's an icon at the right of the return type. Put the cursor over it. The return type. All right, let's pull this up. Patatas, give us a little hint. Notable traits for 2 uppercase. Implement iterator for 2 uppercase. Type item car. So 2 uppercase returns an iterator that yields the uppercase mapping of this character as 1 or more cars. Ah. If this car does not have an uppercase mapping, the iterator yields the same character. Interesting. But I don't know if we can use 2 uppercase. I think they want us to use that function. Let's see. So here it's saying expected 1 of. So let's see, do we mess up our, let's go back to our Stack Overflow, classic Stack Overflow. Oh, I wonder if we need to just say here, what if we just collect? So if we look, I want to look at our last iterator, how they're calling collect. Oh, get out of here. So here they're calling collect. So let's try doing this. Collect, vec, string, running this. Okay, it doesn't like that. It's saying add the type in here. Because it's the type, right? The type is a vector type string. So let's try this. Let me clear this out. Run it. Okay, so let's see. Method not found in string vector string map. So we can't use map because we have a vector of strings. So let's see. Let's see how we can map over list in Rust. So I know we have to use an iterator, but let's see how we're going to do it. Map. Into iter. This looks like what we want. We have a vector into an iterator, map over it. Well, this is reversing it, but we don't care about that. So we can use map. So let's do, but instead of using, we need to do into iter. So let's try words dot into iter, which again will return, it'll borrow. So it's going to borrow. Map word, capitalized word first, and then just call dot collect on it. Let's see if that does it. Method not a field. Oh, duh. I left off my, it's not a field, it's a function. Clear this out. Run iterators 2. Okay, so good. We're one step closer. We need to fix this last one. It says here, cannot find value capitalized words in this scope. So it's for the hello world one. So here we have to solve this. So here we're going to do the same thing. Right? It should still work. Let's see if that does it. Capitalized word, consider a type. We have to give it a type. Our type will be the same as before, vec of string. Okay, so here it's saying no implementation for vec string, string equals string slice. So assert capital words equals hello world. That's because we need to return a string. So it needs to actually join them together. So we don't want to collect here. That'll give us a vector. We need to actually convert it back into a string. So I wonder if we just simply need to do toString. Let's see. Oh, and of course, you know what one of the problems is too? Our type is wrong. So our type is just going to be string, right? And in fact, it's going to be string. So here it's saying no implementation for string equals, oh, it's got to be a type. String slice, run it. Okay, so here now it's getting the actual value. So value type string slice cannot be built from an iterator. So we have an iterator here, right? And so instead of collect, what if we did join? Method not found in iterator. So I think we maybe have to do join like that. Cannot infer type parameter B declared. Okay. So let's look at how to convert a vector into let's look at a join a vector. I'm getting scared here. All right, so let's do how to convert vector into string. How to join vector. How to join vector of strings in Rust. Oh, can we just do join on nothing like that? Is that why I complained? Collect B. So capitalize first. So this map, right, is going to give us, let's see. So collect is going to give us what? Collect gives us let's go ahead and search collect. Collect is giving us, because I want to make sure we understand this. So collect is giving us a vector. Right. So collect gives us a vector. So in the chat, Patatas, do you know you can compare a string with a string slice, right? I did not know. That is interesting. I thought they have to be of the same type to compare. Okay, so let's see. So let's go over what we have here. So words into iterator, we're mapping over the word, capitalizing first. Now we're stuck with a vector. So our vector is hello world, right? But the problem, and it's capitalized, but the problem is we now need to combine them. So we need to join them together. And so when I run the code here, it's saying, cannot infer type for parameter B declared on the associated function collect. So we need to say that collect is going to return a certain type. So I think what we can do here is something similar to up here, where we say the type that it's going to return. So what if we did this? Method not found in string. Well, so collect, let's see if we just do. Can we just collect it into a string? Collect string. Will this work? Let's see what it says here. Expected string slice found struct string. Consider borrowing here. Words into Yes, so it's expecting a string slice. And we are returning a. Can you collect by vec? Like vec exclamation point, use that to collect it? I don't know. But I think what we can do here is, because this is returning a string, maybe we can actually, let's see if we can actually collect it as, let's see if this works. I want to see if we can actually collect it as that type. No, so it can't be built. So we can only build string. And so what we'll have to do is borrow here. All right, so we're almost there. We failed. Why do we fail? Let's see. Here's the output. Left, hello world. Right, hello world. Assert failed. Left equals right. That's on test iterate into string. That's this one. So this was capitalized. So it didn't actually capitalize it. So this didn't actually do what we wanted it to do, probably because we need to, I wonder if it's because we need to just use a regular iterator and not, let me try something. So let's see. Left does not equal right, so we apparently still have hello. Here in this case, test success, left, right, it didn't actually capitalize it. So let's see, did it not actually run the capitalization here? Oh. So we need to call to uppercase, which is exactly what Patatas is saying. To uppercase will return an iterator, and it'll uppercase the first letter, which is actually what we want to do. Got it. I saw it. See, so it's not actually uppercasing it. And then down here, we don't need to do this. I see. I see what you're getting at. See? Sometimes it doesn't read chat. Come on, you got to read the chat. So let's go over what we did because it got a bit confusing there. But basically what we changed here, this was key. So Patatas in the chat with this infinite wisdom showed us that to uppercase returns an iterator, which is great. The reason it's great is because it returns an iterator, we can capitalize the first word using to uppercase, the first letter, and then it's an iterator so we can collect it. So that's important. So very, very good. Patatas is also asking, why are you asking for a string type? We don't have to. We can change this to a string. That should be fine. So we can do just regular string. So we'll change that in a second. But so here what we've done is we've converted the first character to uppercase. We've collected it. So here we're collecting as a string, right? And then we're appending the rest of the string. So this is the key. We're not just collecting it back into a vector, we're collecting it into a string. So really cool that we can do that with collect. I find that awesome. What we did here was, as I mentioned, I was looking for like a list comprehension, or if we were dealing with JavaScript, right? I would have wrote this as, let me just write, right? If this was JavaScript, which we know it isn't, it's much safer, but if I had written this as JavaScript, I would have done something like capitalized words equals words.map, and then I would call it capitalize first, obviously a camel case, passing it the word, right? So words.map will return a new list. So that's how I would do it in JavaScript. And then in Python, I was saying I would do something like, this, which would be a list comprehension, where I would do probably something like capitalize first word for word in words, right? So this is pretty similar though. What we've done here is we've taken words, which is a vector, we converted it into an iterator, and we map over the iterator. And we provided a function. This is an inline function. This may be new because we haven't done this yet in the book really. We've seen it a little bit, but it's an inline function where this is the argument, word, and we're calling capitalize first on word, and it's a map, so it's going to return a new vector, right? So, or in this case, we're dealing with an iterator, so it's going to continue with the new iterator, and then we're calling collecting it into a vector. Notice we did not specify, oops, sorry about that. Notice we didn't specify a type here. We didn't say, right? Because we wanted it to collect it into a vector, and so we're given a vector of strings. So that's what we did here. Here is a little different, and first we're going to try changing this back. Let's run it, see if that still works. Cool. So here what we're doing is, similarly, we're mapping over it, calling word, but the big difference is we're collecting it into a string instead of collecting it into a vector. So we could have wrote this out, I think, in long form. We could have done something like this. And I believe this would still work. Yep. But we don't need to do that. And here, I wonder if we even need to do this because of the type. Let's see. So we don't even need to do it there. Why? Because we've declared the type here. So it's able to infer that we're going to want to collect it as a string. So Patatas in the chat, you can also do collect vec with the underscore instead of specifying the type. It's called turbofish. What is that? To look that up. But so this is pretty great. So we're calling collect because we have the type here. It is able to infer that, right? And so it knows to collect it as a string, and then we just do the test. So pretty cool. Iterators are, this is something I'll use a lot, right? Like I think iterators would be my preferred way of iterating over something rather than a standard for in, but I'm sure each has their case. But this is pretty nice. I like this. So, all right, great. So let's go ahead and remove I'm not done. And let's run our Rustlings watch and see the next step, which will be Iterators 3. So let's open that up. Let's see, are we going to finish tonight? I think we're going to finish. I don't know if we're going to get to the chapter 11, but if not, we'll get to it next week. Let's see how far we can get though. Iterators 3. Whew. Oh, see, it's already starting us out. It's like, yo, it's going to be crazy. Look, this is a bigger exercise than most of the others. You can do it. Here's your mission, should you choose to accept it. A little Mission Impossible, right? Little right? Little mission, little. Should we bust it out? Should we bust it out? Should we do a little? I don't even know it. Nope. What is it? There we go. We got it, right? There it is. Maybe it's actually up here. There we go, a little Mission Impossible for you. I don't know if you could hear that through the mic. We just busted out a little Mission Impossible base because it's asking if we want to accept the mission. We're going to accept it. Step 1, complete the divide function to get the first 4 tests to pass. All right? Uncomment the last 2 tests and get them to pass by filling in the values for x using division results. Okay, so let's do step 1. Complete the divide function to get the first 4 tests to pass. The last 2 are commented out. We need to implement the divide function. So let's take a look at our code. Let's see what we're dealing with here. We have a enumerator here with derive. We're saying that it has the debug trait, partial equality trait, the equality trait, and it's an enumerator, a division error. It's a type. Not divisible error. Divide by 0, another type of error. Here we have debug, partial equality, equality, not divisible error. This is a enum, this is a struct, the dividend, and the divisor, right? Pretty cool. This function should calculate a divided by b if a is evenly divisible by b. Whoa, math? Come on. I didn't get in a program so I do math. No, I'm just kidding. I really, yeah. Otherwise, it should return a suitable error. Okay, this function should calculate a divided by b if a is evenly divisible by b. Again, just a divided by b if a is evenly divisible by b, right? If it's non-divisible, we should throw the proper error. Evenly divisible is the key, right? So we can use the mod here, right? Let's try it out. Otherwise, it returns a suitable error. So let's implement the function. That's what it wants us to do. So here you can see we have A, it's a signed 32-bit integer. B is a signed 32-bit integer. And we need to return, hold on, this is to be turned down. It's like really bright. Much better, much better. All right. And it needs to return a result. And the result is either going to be a, what? It's going to be a signed 32-bit integer or a division error. Okay, let's try it. So what do we want to do here? It should calculate A divided by B if it's evenly divisible by B. If it's not evenly divisible, so we have the struct not divisible error. That's this here. So just saying that not divisible, it gives you dividend and the divisor. Let's look at our test, see what it's expecting. Ready? Test that verify your divide function implementation. So if we divide 81 by 9, we should get 9. That's great. If we divide 81 by 6, it's not evenly divisible. We get a remainder, right? And so we get a not divisible error. If we divide by 0, we should get the error divide by 0. Divide 0 by something else, we should get 0. Okay, pretty standard, right? All right, so first we can do a few things, right? We can handle these cases. It looks like it just wants us to, use iterators. We're in iterators 3, and it wants us to use iterators, but I'm wondering if that's what I need to do here. Let's see. Let's just get it past the tests. So first we can do, of course, if A is 0, we can return 0. So we can just do here. We'll just do a basic statement here. If it's 0, we'll return OK, 0. Now that first test should pass. Oh. We have to make sure we return the correct type. So if B is 0, B is 0, right? We can't divide by 0. We have to return OK. And the error. Well, sorry, we don't want to return OK. We want to return the error. So it's going to be error, and then we're going to create a division error. Division error. Divide by 0. All right, so let's see how that goes. Oh, we also don't need these parentheses. Redundant. So first, what I'm going to do is I'm just going to have it return the division. Obviously, it's not going to work for even division, but it'll give us it'll fail that test, but hopefully we can pass the other tests. Yes, so Patadas mentioned in the chat, it will only divide those that A mod B equals 0. Yeah, so evenly divisible. But it's iterators 3. So let's see. Else if B equals 0, we'll return that. Otherwise, we're just going to, for now, we're going to return OK with A divided by B. So let's run it, and hopefully it should fail some tests. Perfect. All right, so we failed some tests, but we passed some tests too. So divide 0 by something passed, test divided by 0 passed, and one of the tests passes, but one of them fails. And that's the not divisible, right? The mod one. So we could do something like this. A mod B equals 0. So if it evenly divides, return that. Else return, and it's getting ugly with else ifs, so don't worry, we can fix this. Else will return error, and it's going to be another type of division error. And in this case, it's going to be a not divisible. And not divisible is going to be take a struct, right, of not divisible error, new, or we could just do this. And dividend all right, let's see. Cool. They passed, but we still have to uncomment 2 tests. And this is kind of gross. Maybe we can clean this up. Vitalis made a good point. We should check if b equals 0 first, because if a equals 0, you still can't divide 0 by 0, right? If we pull up our calculator here, that's not going to work. So that's a great point. This is logic. And we should maybe, let's write a test for that. I know we shouldn't be adding new tests, but let's write a test for that, because that's a cool example. Let's write a test. I'm going to add another test. This is a great example. We're going to see 0 divided by 0. Right? And it should be an error. Yes, potential PR to Rustlings there. Maybe we should do it. I think it's a good example. I think we should do it. We should do it. Want to do it? Let's do it after this. Let's submit a PR to Rustlings. I love it. Patanis, maybe if you want the credit, you should do it. But I think we'll see. Maybe we'll do it together. But that's a great idea, because I think this is a good use case, right? Error. And the error should be this. Division error, divide by 0. Let's check. Oh, let me get rid of these. Sorry, we don't need these extra parens. Oh, we need to name this. Let's say test 0 divided by 0. All right, failed. Awesome. So now we can fix that. So we'll do if b equals 0. If a equals 0. Whoa. We'll do 0. Save that. Cool. All right, now we have to comment out the last 2, and I'm assuming that this is where the iterator is going to come in a bit, right? Yes, it is. Okay. So let's comment out these. So it says up here, uncomment the last 2 tests and get them to pass by filling in values for x using division results. All right. Let's comment them out. No. Okay. Let's save it. Let's get it to run the test and see what happens. All right. We got to fill in x. Let's see. Numbers, vector. We have a vector. Division results. Numbers into iter. So it's going to iterate over this. And it's going to try to find out which numbers are divisible by 27. It looks like they all are. It's expecting them all to be. Interesting. Interesting. This is interesting. Let's see. So I guess this divided by 27s. Wow, interesting. Okay. Anyway, let's try out filling in x. Division results, iterates over number, calls n. So it iterates it, creates an iterator, maps over it. What is the map function? Given n, call divide with n by 27. So that's our division results. So we're gonna have an iterator, right? What is it gonna be containing? Well, division results, and let's see, is it actually, it should be complaining about, okay, it's not. So we have to fill in x, and x should equal this. So how do we get this? Well, from here, from this iterator, we want to create a vector. We have a vector, right? We want to wrap it in OK. Now, the problem is that each of the values is already wrapped in OK. So if I just set this, let's just set this equal to division results, and we'll see what we're talking about. So if I do that, let me just get it to compile, and then we'll see what it prints out. So let's see what it's printing out now. Okay, so we can see what we're dealing with. All right, so in the first case, what we have going on here is left side is the map, right? It's the iterator with those values. But it's expecting OK1, OK11, and so forth. In the second case, we have these values, but it's expecting them wrapped in an OK. And it's actually expecting, wait, did I make it equal to the wrong thing? Yeah, 27, 97, 81. Okay, so here we have left side is 27, 297, 385, 81, and here's the results. So basically, we're mapping, storing that in division results, calling divide. So let's try to, let's see, what can we do here to make this work? So we need to, let me just take another look at this. So this is just the map. So let's go ahead and try collecting this. And let's collect it as a vector of, well, it needs to be actually a vector of option, or sorry, it has to be a vector of results, I believe. Results, what does our thing return? This. And let's try calling collect. Let's see what that does. Struct with similar name exists, vec. Oh, I called it vect. Huh. Okay. Vec. Let's try that. Okay, so we're closer. So on the first part, now what we're stuck with is OK1, OK11, OK111, 3. Right? We want it to look like this. So I'm going to try doing something, a little sketch. I'm going to try seeing if instead of returning this, I'm going to change this here. I'm going to say, I want a let's see if this works. I want a vector of 32-bit integers, but I want a result of that, or a, I guess, division error. What do we call it? Division error. Let's see. Let's see what happens. Damn. We figured it out. What did we do there? Let's just talk about that. What do we do? What do we do? What do we do here? Collect. Collect is crazy. Collect knows. It knows what we want. Basically, what I did first, let's go back over this really quick, because I think this is pretty cool and super powerful. So first I said, okay, I want collect to return me a vector. Remember we did this before, we returned strings. I want it to return me a vector. And I'm saying that I want the type of it to be a result parameterized over a signed 32-bit integer and a division error. So this is actually the return type of my division function. And so I'm saying I want a vector of those, which makes sense because divide will return that. And so what I got when I ran this is I actually got a vector of, sorry, here. I got that. I got a vector of results. But what we actually want is a result with a vector of signed 32-bit integers. So I said, okay, instead of modify my code, let me just modify the type here and specify that what I actually want is a result. What kind of result? Well, I want it to either, in the successful case, be a vector of signed 32-bit integers, or I want a division error. I save that, and it passed. So it actually is returning me the correct thing, which is really awesome. And we can see that by, if I did copy this, I'm just going to print it here. Oh, we probably also want to do it on the separate line. But anyway, instead of just setting equal to division results, we could probably do it on 2 lines. But let's just do this really quick, and then we'll change the function. So here I'm printing it out, and you can see. Wait, can you see? Where is it? Where to print? Where to print? Ah, here. X is perfect. So that actually worked. So really, really cool. I think that's pretty awesome. All right, so what are we going to do? Let's clean this up a bit. So let's go back to what we had. And let's clean this up. Instead of doing this all on this line, what we'll do is we'll say x equals a result of vec I32, comma, division error, and we will do the collect down here. And it'll just be division results dot collect. Let's try that. Cool. We are all good. Now we got to get this next one to pass. So the next one, it actually is what we did originally. It expects a vector of result types. So that's basically what we had tried the first time. So what we're going to do is just copy this down here. Instead of being a result of vector integer 32s or a division error, we're going to do a vec of what type? Well, it's going to be results that either has an OK of integer 32 or a division error. Oh. X is a vec, results. I left off a greater than symbol. Voila. Look at us. We didn't even learn these yet. We're crushing them. We're crushing them, right? We got the mission. We did the Mission Impossible theme. It said up top, should you choose to accept the mission? Look, here's your mission. We were just like, right? Hit him with the Mission Impossible theme. You can't Tom Cruise me. Can't Tom Cruise me like that. We did it. Iterators 3. All right, on to the next one. Why? We have to get rid of this. On the next one. Can't Tom Cruise us, right, chat? We're Rustlings now. We're Rustations. We're Rustlings. We're not full Rustations yet, maybe. Maybe some of you are. Patatas, you are. In the chat. You gotta be. All right. Let's go. Factorial. All right, ready? Let's open up Iterators 4. We're going for it today. We're going to finish Rustlings. Patatas got division working with match. Yes, we could definitely clean this up. We could definitely do a match. But let's move on. Iterators 4, look, no instructions. Now, here's the instructions. Complete this function to return the factorial of num. Do not use return. Try not to use imperative style loops for a while. Additional variables. For an extra challenge, don't use recursion. Execute Rustlings hint, Iterators 4 for hints. Factorial. Who remembers what a factorial is? Who remembers it? Patatas is giving us a link to Play Rust. If any of you haven't checked out Play Rust, it lets you view running Rust code. We're going to pull up Patatas' version of this where he used a match. Let's take a look at this. Patatas is a full Rust station. You are a Rust station, sir. Or madame. We don't know. All right, so here's how you did it. So divide, same thing here, but look at this. Look at this beautiful match. I love this. Match A, B. This is really nice pattern matching here. It's saying who cares what A is. If B is 0, return this. If A is 0, who cares what B is? Return this. And then this is an AB if matches, right? We learned about this. If matches this, okay this. So if it matches this here, we're good. That's pretty cool. And then otherwise an error. That's awesome. This looks so nice. It's so readable. I love this. Much nicer than, we had dark mode. No, we can't. Ah, yes we can. Chaos. Clouds Midnight. Monokai. Let's go Monokai Industrial. Look at that. This is so nice, so readable. Patatas is awesome. I love this. I love this version of it. Really, really fantastic. Nice job. All right. Factorial. Who remembers what this is? Who remembers the math? We're going to look it up. I don't remember. It's going to come to me and they're going to be like, Tom, how are you a functioning adult who works a job as an engineer and you don't even know? Jeff Ronius in the chat's giving us factorial. Of course. Of course that's what it is. You're the best. Function for a factorial. Now, question though. No, this makes sense. All right, factorial. Okay, this is the formula. We can't use recursion? Come on. I would definitely use recursion for this, but they don't want us to do it. We're going to use an iterator. They're like, use an iterator. It's called Iterators 4, Tom. What are you doing? Use an iterator. Clearly, that's what we want you to use. Recursion. All right, so let's try using it. And don't use return. That's okay. It's basically telling us we can do this in one line if we're crazy. That's what it's saying. It's like, oh, you're crazy? Do it in one line. All right. Can we use reduce? Can we use reduce? Is that a thing? Is that a thing? Let's look. Iterator, Rust. I need reduce. Please have reduce. Or fold. Maybe it's called fold. 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 You know we're using fold. Fold first. Which direction? Can we fold left and right? What's the deal here? We're going to find out. Factorial is the best order for now. We're going to have. Oh, yeah. There's someone on Twitch who likes to do advent of code using only iterators. So we can have a 2-line solution. That's cool. I'd much rather be able to read the code, though. But props to that person. That's pretty interesting. Is it you? Doo-doo. No. But yeah, so all right, let's see. Fold. So fold, those of you, the reason I'm looking for fold, if you've used reduce in JavaScript, I'm a huge fan of it. I've used it for doing things like computing the sum of a list. The beauty of it is that you can reduce something down, right? So you can take a list of things. So what we're going to do is we're going to have a range, right? We're going to have a range from 2 to n. You can take a list of a range of things and reduce it down to a single value. And the way you do that is you take an initial value and each item of the list, and you modify that initial value, and the output of that function run is the input of the next iteration of the function. So it's just like reduce. And fold is basically the same thing, but in functional languages we call it fold because it's folding over, right? If you have a sheet, it's almost like you're, folding the sheet over on itself. So it lets you take something larger and bring it down to something smaller, or convert something of a certain type to another type. We often use it in JavaScript to convert an array into an object with certain key values, things like that. So fold is what I'm looking for here. That's the way I'm going to try. I'm sure there's other ways to do this, but fold stood out to me. And generally, fold can work in two directions. It can work from the start of the list to the end, aka left to right or right to left. So in this case, let's read the description of fold and see if it's going to be good for us. So fold, an iterator method that applies a function producing a single final value. Fold takes two arguments, an initial value and a closure, with two arguments, an accumulator and an element. The closure returns the value that the accumulator should have for the next iteration. So that's the folding nature. The initial value is the value the accumulator will leverage on the first call because it hasn't yet invoked the function. It needs to have an initial seed value. After applying this closure to every element of the iterator, fold returns the accumulator. This operation is sometimes called reduce or inject. I've never heard it called inject. That's interesting. I wonder what language that is, but I've definitely used reduce. Now, folding is useful whenever you have a collection of something and want to produce a single value from it. Note, fold and similar methods that traverse the entire iterator may not terminate for infinite iterators, even on traits for which a result is determinable in finite time. Interesting. So here's a usage of it. We're going to do something very similar. Let's try it out. Let results. We don't need that. So we're going to do a range. To num, right? Dot iter dot reduce or fold. Let's see what it's going to complain about. And for fold, we take an initial value. Oops, sorry, ass noises. The initial value is going to be 1. 1 is fine, right? 1 can work. We want to go from 2. We want to multiply this all by 1. That'll be itself, right? So 1 is fine for an initial value. Now we give it that closure, right? And that's that inline function here. So we're just going to do this, and I'm going to go over what this means. This is the accumulator. This is going to start out as 1, and it's going to be whatever's returned here is going to populate this on the next run of the fold. So we usually call this a accumulator. I usually call this current or cur. And so what we're going to do is we're going to do accumulator times cur. And that'll give us a single value. So that should work. Method not found in range iter. So we used a range there. So I need to do, can I do this? Is this going to be a thing I can do? Can I do vec? Create a vector from that range? A macro with a similar name exists. Vec. Duh. Can I do this? Oh. Cannot multiply a range U64 to U64. Okay. Let me see here how to create vector from range Rust. I don't want to shuffle it, but I just want to see how to create it. Oh, collect. Collect will create a vector for us. Oh, iterators. So we can just use collect. So we could do, and we can also specify the type here. So check this out. It says here, we have to surround the whole thing in angle brackets, right? We forgot, because the type that we're collecting is a vector. We actually just need this, right? We're collecting these into a vector of unsigned 64-bit integers. Method not found in vec64 because we can only fold on an iterator. So let's see if we can just leave that off. Okay, cannot infer the type. So we want it to be an iterator. Let me see something. So Batata said this should work. Let's see why it's not working. Oh, well, that's because of that. Let's see why this doesn't work. Ah, so this worked. Instead of using the iterator, we were just able to use this. Interesting. And that's because this range is iterable, I guess. Ah, so Patatas mentioned the range is already an iterator. Oh, that's perfect. This is much nicer, much simpler. So let's see what went wrong. We're failing, but that's okay. We can find out why. So assert the factorial of 1 is 1. That makes sense, right? 1 gets put in here. 1, right? So initial value is 1. This is the function we're running. And so the initial value comes in as 1. The current value would be 2. 1 times 2 is 2. Let's see, why is this one not working? What did we get for these assertions? So the left expected 2, but the right was 1. Left expected 24, but the right was 6. Why is that the case? Is my fold wrong? Clearly. Okay, so what did it pass here? It passed factorial of 4. So it passed 4, so we got a range from 2, 3, 4. And it just added them? What did it do here? Range starts from 2. But it should start from 2, right? Because we want to do 2 to the number. Right? Let's see. Oh, it's also not inclusive, right? Isn't it not inclusive? That's why. That's right. So it was going to 1 below the number, which makes sense because when it was returning 6, right, it would have multiplied by that. So that's, you can see how fast factorials grow. But yeah, so it's, and I would probably even like to do something like this. I don't know if this is appropriate, but. So we need to go 1 more than the number because ranges are exclusive on the second value, aka not inclusive, exclusive, right? Consider the case of factorial 1. Yep. All right, so we're all good. Great, we did it. We're getting through it. That was pretty fun. Thank you for the factorial function, Jeff Erroneous, and thank you for the tips, Patatas. Awesome. All right, traits 1. So we are not going to finish Rustlings tonight. Wow, we thought we would. Maybe we will. How many? Let's see. What else do we have left? Let's go to our exercises file where we have the list of exercises. Actually, I think it's in a YAML file. Let's see, what else do we have? Traits. Threads. Oh yeah, we're definitely not going to finish it. We have threads still, standard library types. We went over that, we did that. We're doing that now. Traits. Threads. We haven't done threads yet. Let's see, we're at what time? Let's see, let's try to wrap it up. So let's go to iterators, traits 1. Maybe these are easy. We learned about traits. Traits 1. Time to implement some traits. Your task is to implement the trait append bar for the type string. The trait append bar has only one function, which appends bar to any object implementing this trait. All right. So, implementation, append bar for string. It appends bar to any object implementing this trait. So, we can do self and it's a string, so we'll do self. Oh, we can call append. Oh, wait, let me see something. Append bar for string. I think we have to use this. Let's see. Let's just try this and see what it complains about. Missing append bar in implementation. Ah. Missing append bar in implementation. What does this say up here? Oh, weird. All right, and here we need self. All right, let's see what we're doing here. Okay. I cannot modify the signature. So here's the trait. Okay, so take self. So I can't modify the signature. Oh, what have my Rustlings watch? So let's go back. You know what I'm going to do really quick? Because we've done something similar. I'm going to go into our Learn Rust Live code and take a look at how we did traits before. Because this will be a fun... Right? This is code that we wrote anyway, so let's take a look at it. So we did generic types and traits. In traits, we have main, and we have some trait implementations. So here we had an article, we had a trait called summary, summarize author, summarize, right? So we just create these functions, trait summary, implementation for summary, for news article, summarize author. It just needs to have the signature, and we're just implementing it down here. So as long as it maintains that signature, we're okay. So let's go back to our other thing here. So we just need to implement this signature. We're implementing it for string. Let's see. Good. So we kept the same signature, we just implemented it, and there we go. All we did was we took self and returned self. In this case, self is just a string, right? Because we're dealing with strings. And we just do string appending. And that's it. Next, on to traits 2. Traits 2. Your task is to implement the trait append bar for a vector of strings. To implement this trait, consider for a moment what it means to append bar to a vector of strings. Right? So maybe we add it to the end. Do we combine the vector of strings? Right? No boilerplate code this time. You can do this. Yes, we can. And we can look at the previous one to help us. So again, we need to implement this for a vector of strings. And it says here, take a moment to think about what it means to append bar to a vector of strings. Well, let's look at our test and see what they expect. It could mean just append bar to the end of the strings, or it could mean that for each string in the vector, we want to append bar to that string. Let's look at what it says. Foo, vex string from foo, append bar. So they call append bar on this vector. Then they unwrap it, string from bar, they pop another one, string from foo. So it just appends bar not to each string. It's just appending it to the vector. So we have trait append bar, and so we can do implement append bar for, and we need to do it for vector. Can we do it for a very specific type like this? Let's find out. And then we have append bar self, return self. And what are we going to do? We're going to do self dot push bar. Let's see if that'll do it. This call modify self in place. You probably want to use the value after calling this method instead of the output method of the push. Right, so this doesn't do anything, so we need to return self. Expected struct string up. Silly me. We can just do toString, or we could do string from, right? Consider changing this to be mutable self. We don't want to do that because we don't want to change the signature. So instead what we can do is we can do, let's see, we can, instead of making it mutable, what we can do is let new self equal push. We're going to push bar into that. Push string. So Patah said push string. Let's take a look at that. Push str. Let's see what push string does. Instead of using the plus. Yeah, we could do that instead of the plus, but since we have a vector here, we'll need to use this, I think. So let's see. Let's see if we can do it this way. I did it again. There we go. So what do? We implemented it by creating, right, a mutable new self equal to self here, right? And then new self push, and we're pushing bar as a string, and then we're returning new self because this returns unit type, so we can't just return this. So instead we return new self, and we're good. It works. Next one. What are we on to next? Traits 3, generics 1. See, we got a lot left. We are definitely not going to make it through all this. Where's generics? I feel like there's not much left. Generics, right? We can see the ones we haven't touched yet. They're in gray in my editor here. So threads, generics, conversions. Yeah, we're not going to make it through, but that's all right. We're going to get as far as we can. This has been really fun. And if we have more, then we have more. Generics 1. This shopping list program isn't compiling. Use your knowledge of generics to fix it. Well, this is easy. Generics, we know about generics. Let mute shopping list equal new. It expects it to be, it's calling push on it, passing a string. So of course it's going to have to take a string. And in fact, it's going to have to be a string slice, right? Because it's not using a regular string here. That should do it. Good. We knew that. We've learned generics. See how easy it is when we've learned the stuff? Man, it's great. All right, generics 2. This powerful wrapper provides the ability to store positive integer value. Rewrite it using generics so that it supports wrapping any type. Okay, I like it. Wrapper, value. Right now, it is unsigned integer 32. We're going to make it a T. Implement wrapper, public function, new value. We're going to make it T. T is just the generic type, right? It's over type T. I think we also have to do this, right? Let me pull this up really quick. Let's take a look at our previous examples of dealing with generics here. Generics, we're here. How do we do it again? Let's see. Oh, yeah, we did T. Oh, okay. That's what we got to do. So value is T. So that was right. So that part's right here. But we have to make the struct generic over type T to be able to use it, right? So that should do it. And of course, wrapper T. So here we have value not found in the scope. Value T. Let's see, how do we do that? Point T. Implement. Right, it's got to be in front of the implement to be in scope, right? We have to bring it into scope. So here we need to say T. We did it. So again, what we did was we made our struct wrapper generic over type T. We were then able to use T. We then had implementation. Of course, you had to define it over type T, and then you can use it here. And we're just passing T, which lets us use a generic type. Now we could be more specific and say that, oh, what up? We got James Harries. Thank you for the follow. Appreciate it. Welcome to the stream. So what we're doing is we're using T. Of course, we could be specific. In this case, since it's only using unsigned 32-bit integers and foo, we could even say that it only accepts things that support the copy trait, right? We can get specific with it. And we've done that here where we've made sure that it implements a particular trait. So let's try that for funsies. So we know that unsigned 32-bit integer and string slice meant the copy trait. So what if we did that? Let's try it. And again, we're just looking at, this is an example here. We can see generic over type T that implements, or that has the trait partial order, right? And I think we have another example of that being used, but I'm not totally sure. Let's try it. Let's see if it works. I don't think we need it there. Let's see. Yeah. We are still good. Awesome. All right, so let's move on to the next one. So we'll get rid of the I am not done. And I think we're on generics 3. Generics 3. Gary Plotter, what is this? All right, so let's go to generics 3. And here we go. We're almost at 11. I think what we'll do is we'll finish up generics and then we'll call it and then we'll wrap up next week. We don't have that much left, luckily. All right, generics 3. An imaginary magical school, not Hogwarts, I guess, has a new report card generation system in Rust. Wow, good for them. Why does that have to be imaginary? Why can't a real school have this? Come on. Come on. Currently, the system only supports creating report cards where the student's grade is represented numerically. Example 1.0, 5.5, so we're doing floats. However, the school also issues alphabetical grades, A+ through F-, and needs to be able to print both types of report cards, right? So it needs to be able to do numerical or alphabetical. Make the necessary code changes in the struct report card and the implementation block to support alphabetical report cards. Change the grade in the second test to A+ to show that your changes allow alphabetical grades. All right, let's do it. Let's do it. So struct report card, grade F32, right? Right now it's failing. Why is it failing? Because we gotta check that. We gotta be able to accept A+. And so if we look at our tests, this one works fine. Tom Riggle. It's a weird name. It's not my name. And here we're checking that we can, they want us to change this to A+, and check that it still works. So we don't have to make 2.1 map to A+, we just had to make sure it works after we changed it to A+. So what can we do? Well, we can make our public struct report card generic over type. Let's start with T, and then we'll get more refined. We'll get more specific. So we'll start with type T, and then, yeah, we'll be specific. We'll say it's going to either have to be this type or this type, right? So we'll start with generic over type T, and then here we have our, what function are we calling? So we're creating the report card, and then we're calling print. So we need to implement print, right? And here you can see print returns a string. And so it's calling format, achieve grade of blank, and it's formatting student name, student age, and grade. So what do we know? We know that whatever we're passing as T needs to implement display, right? It needs to be able to implement display. So if we try to save this here, we're going to immediately get an issue because, well, first of all, we didn't do this. So let's see, it's going to complain. Right, so it doesn't implement display. And we know it needs to implement display because we're trying to use display. So what if we are specific here and we say that T should implement the trait display? And of course, we'll do that here. Display not found in the scope, and that's okay. All we need to do for that is we can either use the full name or we can just use it. So we'll just pull this in here. So we just have to do use, oh, let me make sure there's nothing above here. Okay, so use standard format display. And this is a trait, and this is the trait that when we've been using println, we've actually been leveraging. And you also have seen us use the debug trait as well. So let's go ahead and run our Rustlings watch. Obviously you can see all the successful things we've done. And yes, we have to change it to A+ in the test. So we'll do that once we get this to compile. So generics are really cool. Very, very powerful stuff. Very powerful stuff indeed. Okay, great. Similar trait display defined here. Trait with similar name exists. Display. I called it display. I like display. I think it's a nice way to say display. Display. All right, let's see. Cool. So now we're good, but our test failed. Let's change our test down here to A+, because that's, I'm definitely, Glary Potter is getting an A+. You know, Glary Potter's been studying. And we did it. We did it, family. We did it. So let's get rid of I'm not done and see what's next for us next week. Threads. I'm excited for threads. We haven't learned about it. It's going to be rough. All right. Awesome. So we made it through generics. We did traits. What else did we do today? We did... What else did we do? Generics, traits. Oh yeah, this one. Standard library types. Arc, box, iterator. So this is awesome. Had a lot of fun with it. I'm going to be pushing this code up so anyone can take a look. But this was a really fun one. So what we'll do next week is we'll finish up the last part of Rustlings. I was hoping to finish up today, but that's okay. We had a lot of fun. I'm having fun with the exercises. I like it because the chat gets to be really engaged. And if you're watching on YouTube, I hope you're able to enjoy it as well. And, you know, just keep up with it. We're going to finish it. I'm excited. Again, as usual, gotta plug it. But you can find all of the previous videos here on the YouTube channel. Just search my name, Tom McGurl. We got the 2 Rustling ones we did prior to this. This video will go up tomorrow. It'll be usually up in the afternoon. If you're watching the video, you know it's already up. I want to also give a shout out to Jeff Ronius in the chat for showing up today. He made it on time. And he says, thanks for the stream. Thank you, Jeff Ronius, for popping by. I appreciate it. Also, thank you to James Harris for the follow and DN Bra for the follow. Also appreciate that. So definitely check out the YouTube video, YouTube channel for all the latest videos. I'll be posting off some more one-up content there as well. hit that subscribe and like button. Classic streamer call out, but do it and you'll get notifications. You can get up to date when all the content goes live. Obviously, follow me on Twitch. You'll know when I go live. And then follow me on Twitter. I also do go live posts. I'll do some other posts. You know, if you're interested in Rust posts and things like that, I'll be posting that stuff there. Obviously, we got posts like this, quality content from our Halloween stream. Everything's going to go up on GitHub. I haven't pushed the Rustlings up yet, but I will do that. And yeah, this has just been a lot of fun. Thank you, everybody, for hanging out and coming out tonight. This has been a really fun stream. I've been really enjoying the Rustlings. Special shout out to Patatas, who's been showing up on Tuesday with the help, the assists. Really awesome having someone in chat to kind of bounce off of. Jeff Veronius, thank you as well with some awesome info and tips. Gave us the Factorial function. That was really fun. If you're watching on YouTube, thanks again as always. Please feel free to put some comments down below if you have any questions. Happy to answer them. A lot of people asking what my editor theme is. I'm using Monokai Ocean. Monokai Ocean. It's a great theme. I'll put that in the show notes too. But yeah, feel free to drop a comment, subscribe, get those notifications, and we'll be doing this again next Tuesday, 9 p.m. to 11 p.m. Eastern Time. Thank you, everybody, for hopping on tonight. Thank you for those of you watching on YouTube. I really appreciate it. I hope you're enjoying the content, and there will definitely be more. Everybody have a good night.